Hello friends, let us inscribe into a sphere a cylinder with the biggest volume. Is it possible? Well, let's see. So that would be a sphere with a given radius r, something like that. And I would try to put a cylinder inside of a sphere like that. All right. So how can it be made uh, as large as possible considering the volume? Well, you see, we need some information. Of course, this is extreme value question, and this is a topic about now. So this is the diameter, which is equal to 2 times the radius. This is the height of a cylinder H, as you can see, so the orange side. And in this triangle, we also have, so this is a right angle triangle. This is the radius of the cylinder. Let's call it small r. This is capital R. And as you can see, so basically our goal is to maximize the function of the volume, which is dependent now on two variables, h and small r, and that would be pi small r squared times h. Should be maximized. All right. But what do I have here also? I have, you see, this is like 2r, so 2r squared plus h squared equals to 2 capital R's squared. So what can I do now? I can try to solve it for, well, rather r squared, as I would say, because if I solve it for h, I have to put a square root. I don't want to do this. So this is, of course, the Pythagoras theorem, which is applicable here because we do have a right angle right there. So we got 4r squared plus h squared equals to 4 capital R squared. And if we would like to solve it for r squared, I'll bring h squared to the right hand side and I'll divide it by 4. So r squared equals to capital R squared minus a quarter of h squared. Hope I didn't make any kind of mistakes. Now, the capital R is the given radius of a sphere. We have to know that, so this is a constant value. Our function is now a little bit changed, so let's see what had happened. So we have the volume function dependent only on a capital H now, because small r squared, in this case, is just being substituted. So we have pi, parenthesis opened, r squared minus a quarter, h squared, parenthesis closed, times h. So this is the function we have to maximize now, and this is, well, relatively easy to follow, right? So we just have pi capital R squared times h minus pi divided by 4 h cubed. Let's figure out its derivative. I think I have to do it on the next page. So this is the volume of h. Let's repeat it in order to avoid mistakes. These are the most common mistakes. Pi r squared times h minus, what do we have? Pi divided by 4 h cubed. Okay, so what is its derivative? Well, you see this is just pi r squared minus 3/4 of pi h squared. Now we have to solve it for h. We put it equal to 0 and solve it for h. That would mean we got 3/4. I can skip pi, right? H squared just equal to r squared. We multiply times 4/3 and take a square root. That means h is equal to square root of 4 is 2, square root of r squared is r, plus minus normally, but obviously h can be negative, and we keep the square root of 3 in the denominator. Would that be a positive value, a maximum? Well, let's see. I have to do the second derivative here as well. That becomes 0, and then we got minus 3/2 pi h. So if I substitute this value, which is of course positive, what would be the outcome? It would be negative. So anyway, it's negative. So for sure we have a max. So easily done. So this is the h value. Can I also compute the the small r value? Well, I should. The question was to figure out the measures. So this is capital R squared minus 1/4 of h squared. So that means r itself, I do have to put a square root here, is capital R squared minus 1/4 of h squared. Am I right? Yeah, seems to be fine. So that would be still r squared here minus 1/4, and now we square this value, which is 4r squared divided by 3. So we can cancel those two. Now we have one total r squared. We subtract 1/3 of r squared here, so we're going to get 2/3 of r squared. We can take a square root out of r squared, but we cannot take a square root easily out of 2/3, so we keep it this way. All right, so with this h and with this small r, so a cylinder with that height, which is 2 divided by square root of 3 of the radius of a big sphere, and with this radius of a cylinder with capital R, the radius of the sphere times the square root out of 2/3, we're gonna get the biggest, the greatest volume which is possible to bring into this kind of sphere. Thanks for watching. If you have any questions, write down in the comments. See you guys in the next video. Bye bye.